What's poppin', dogs? Mr. Allen here, and we have ourselves quite the doozy of a problem. We want to graph p of x if p of x is equal to f of x times g of x times h of x, and we don't have any equations here. We just have three graphs. What? Well, let's think about this for a sec. We got three lines here, linear graphs, right? A linear times a linear times a linear is going to give me a cubic. So I'm looking at getting a graph that either looks like this guy right here or this guy right here. This would be if it's positive, this would be if it's negative. So how would I know which one's which? Well, this has a negative slope to it, while these two have a positive going up into the right slope to it. So a negative and two positives would be negative. So it's going to look something like that, maybe not quite as drastic, but it's going to be going down and to the right. Okay, so we got one part here. Now, let's start plotting some points, shall we? Well, I'm going to do some easy ones first. Easy-ish, right? I'm a math dude, right? So a lot of these things are easy. They're not always easy. Okay, so I got f of x here, right? Well, if I plugged in 1 for f of x, my function value is 0. And 0 times anything else is just 0. So do I even care what g of x and h of x are? No. It's just going to be 0 right there. And if I plugged in, say, 3 for x, well, I'm going to get something else for both f of x and h of x, but g of x, when I plug in 3, is going to be 0. And then 0 times the other two, doesn't matter, it's still going to be 0. The same is going to go over here if you haven't already observed or guessed or just been like, pondered perhaps. Negative 2 going into h of x, that's going to give me my function value of 0, and then 0 times anything else is still going to be 0. So I have my three zeros, my 3x-intercepts here on this graph where this guy's going to be going through. So it's going to probably look something like that on here, right? That's my x-axis, and I got 1, 2, and 3 x-intercepts. Anything else that we could find here? Well, just for fun here, let's go ahead and figure out one other point. How about my y-intercept, okay? So for my y-intercept, if I'm plugging in 0 for x, I've got negative 2 down here. I have 1 right here, and I have 2 right here. So negative 2 times 1 is still negative 2. Times 2 gives me negative 4. That means that my y-intercept is going to be negative 4, right? I took out all three of these function values, 2, 1, and negative 2, multiplied them together, boom, I get negative 4. So now I can see that my graph, it's going to start by going down first. So I'm going to start up here. I'm going to go a little bit past it. Wee, come back to my y-intercept. Up, woo, back down. Ah, dang, son. That looks dope. It looks kind of like that guy right there. Even a little more drastic. That's pretty fun, right? But I got all these points, all 4 of them. I now have this cubic that was created by multiplying all 3 of these graphs together without even knowing their equations, right? If I wanted to, I could write all their equations and write it out in factored form, and it would be a cubic function in factored form, which I could multiply out into standard, aka general form. I mean, the sky's the limit here, but I think I'm going to stop right here because that's pretty dang dope. You guys have a great day.